In this video, we're going to go over sine, cosine, and tangent, basic trigonometry stuff. So let's begin. Let's start with the right triangle. So this is the box which represents the 90-degree angle, and let's say this is our angle theta. Now, which side is opposite to theta? Opposite to theta is this side on the right. So that's the opposite side. The adjacent side is the one that's right next to it. And across the box is the hypotenuse, always. Now there's something called SOHCAHTOA. You want to be familiar with this abbreviation. Let's start with the SO part. S stands for sine. Sine theta, that's the S part, is equal to the O, or the opposite side, divided by the hypotenuse. So O is for opposite, H is for hypotenuse. So that's the sine ratio. Now let's consider the cosine ratio. C stands for cosine. Cosine theta is equal to the adjacent side divided by hypotenuse. So A stands for adjacent, H is the hypotenuse. And then we have TOA. Tangent theta, that's the T part, is equal to the opposite side divided by the hypotenuse. Now, there's some other formulas that you need to be familiar with. Secant theta is the reciprocal of cosine. And cosecant theta is the reciprocal of sine. So cosecant is 1 divided by sine. Cotangent theta is equal to 1 over tangent. Also, tan theta is sine theta divided by cosine theta. Therefore, cotangent theta is the opposite. It's cosine divided by sine theta. Now, there's some other stuff that you need to know. So let's redraw the right triangle. Now, there's something called Pythagorean theorem. Let's say this is A, this is B, and this is C. So A squared plus B squared is equal to C squared. So that's another formula that you should know. Now, the next thing that you need to be familiar with are the quadrants. So this is 0, 90, 180, and 270. 360 is the same as 0 degrees. So between 0 and 90, this is quadrant 1. X and Y are positive in quadrant 1. Between 90 and 180, it's quadrant 2. X is negative in quadrant 2, but Y is positive. Between 180 and 270, that's quadrant 3. X and Y are both negative. And the other one, the last one, that's quadrant 4, where X is positive and Y is negative. So let's say if sine theta is equal to 3 over 5. How can you find the values of the other 6 trigonometric functions? So if sine theta is 3 over 5, what is the value of cosine theta? So since sine is positive, it can be in quadrants 1 or 2, but let's assume that it's in quadrant 1. The angle theta is always going to be between the x-axis and the hypotenuse of the triangle, if it's in a standard position. So we know that sine theta is equal to opposite divided by the hypotenuse, based on SOHCAHTOA. Opposite to theta is in this position. Now, where's the hypotenuse? Keep in mind, the hypotenuse is always across the box. So the missing side here is 5. Now, what is the other side? What is the value of the adjacent side? Once we find the third side of the triangle, we could figure out sine, cosine, tangent, everything else. So let's use the Pythagorean theorem to solve for the missing side. So a squared plus b squared equals c squared. Let's assume the missing side is a. This could be a, this could be b, it doesn't matter. But c is always the hypotenuse. That's what's important. So a squared plus 3 squared is equal to 5 squared. 3 squared is 3 times 3, which is 9. 5 squared is 5 times 5, and that's 25. So if we subtract both sides by 9, 25 minus 9 is 16. So a squared is equal to 16. To solve for a, you need to take the square root of both sides. So the missing side is 4. This is a special triangle known as the 3, 4, 5 triangle. There are also other special triangles that you should know. There's the 5, 12, 13 triangle, the 8, 15, 17 triangle. There's the 7, 24, 25. There's the 9, 40, 41, and the 11, 60, 61. Now that we have all three sides of the triangle, let's figure out what cosine theta is equal to. So cosine theta is equal to the adjacent side, which is the 4, divided by the hypotenuse, which is 5. So cosine is 4 over 5. Now what is the value of tangent theta? Based on SOHCAHTOA, tangent is opposite over adjacent, O over A. Opposite to theta is 3, adjacent to it is 4. So tangent theta is 3 over 4. Now what about cosecant theta? What is the value of cosecant theta? Remember, cosecant is 1 divided by sine. So it's the reciprocal of 3 over 5. So cosecant theta is 5 divided by 3. Now what about secant theta? Secant is the reciprocal of cosine. So if cosine is 4 divided by 5, secant is 5 over 4. Now what about cotangent theta? Since tangent is 3 over 4 and cotan is 1 over tangent, cotangent is 4 divided by 3. Try this one. Let's say cosine theta is equal to negative 5 over 13. And also, sine theta is greater than 0. Go ahead and find the other 5 trigonometric functions. Find their values. So the first thing we need to decide is where to draw the triangle. Should we draw it in quadrant 1, quadrant 2, 3, or 4? So notice that cosine is negative and sine is greater than 0, which means sine is positive. Cosine is associated with the x value, so x is negative, and y is associated with sine. So if sine is positive, y is positive. So x is negative in quadrants 2 and 3, that's the left side. Y is positive in quadrants 1 and 2, that's the top side, the upper two quadrants. So you can literally just plot it. X is negative as you go to the left, y is positive as you go up. So it's in quadrant 2. So let's turn this into a triangle. And theta is going to be in the standard position. So if cosine is negative 5 over 13, where should we put those numbers? Now we know that cosine is adjacent over hypotenuse based on SOHCAHTOA. So if you focus on the CAH part, you can see that cosine is adjacent over hypotenuse. So negative 5 should be on the adjacent side, and 13 is the hypotenuse. Now it makes sense that x is negative because as you go to the left, it should be negative. The hypotenuse is always positive for these types of problems. So now we got to find the missing side. Now notice that this is a special triangle. It's the 5, 12, 13 triangle. So this is 12. Now is it positive 12 or negative 12? In quadrant 2, the y is positive since it's going up. So it's positive 12, not negative 12. Now keep in mind, you can also calculate 12 by using the Pythagorean theorem. A squared plus b squared equals c squared. But here's how you can do it mentally. If you're looking for the hypotenuse, add the squares and then square root it. If you're looking for one of the legs of the triangle, either A or B, subtract the squares and then take the square root of the result. So let me explain what I mean. What is 13 squared? 13 squared is 169. And what's 5 squared? What's 5 times 5? 5 squared is 25. Since we're looking for one of the legs of the triangle, take the difference of the squares. What is 169 minus 25? 169 minus 25 is 144. And then square root the result. The square root of 144 is 12. So that's how you can find the missing side mentally in your head. But it helps if you know your special triangles. So now let's finish the rest of the problem. So what is the value of sine theta, since cosine theta is negative 5 over 13? Sine is opposite over hypotenuse. Opposite to theta is the 12, and the hypotenuse is the 13. So sine theta is positive 12 over 13. Now what about tangent theta? Tangent theta is opposite divided by the adjacent side. So therefore it's 12 over negative 5, which is the same as negative 12 over 5. So now let's look for the other three functions. So what is the value of secant theta? Now secant is 1 over cosine, so we simply have to flip this fraction. So it's going to be negative 13 over 5. Now what about cosecant theta? So if sine theta is 12 over 13, cosecant theta, which is 1 over sine, is 13 over 12. And finally, cotangent theta. If tan is negative 12 over 5, cotan is negative 5 over 12. Now, let's say if you're given a question that goes like this. Given the terminal point 4, negative 6, find the values of sine, cosine, and tangent, given a terminal point. So if you're given a point, how can you figure out sine, cosine, and tangent? So for a question like this, you want to draw a graph and then plot the point, but as you plot it, turn it into a right triangle. So x is positive, so we need to go 4 units to the right. Y is negative, so we need to go down 6 units and then turn it into a triangle. So here we have the hypotenuse and theta in a standard position. So now we got to find the missing side. We're looking for the hypotenuse. 4 squared. By the way, we need to find the sum of the squares if we're looking for the hypotenuse, the longer side. If you're looking for the legs, one of the shorter sides, then you need to find the difference of the squares. So we're looking for the sum of the squares. 4 squared is 16. 6 squared is 36. 16 plus 36 is 52. So the hypotenuse is the square root of 52. I'm going to write 52 for now, but we can simplify it, which I'll discuss later. Now, if you don't like to do it this way, you can always use the equation. A squared plus b squared is equal to c squared. So c is the hypotenuse, that's what we're looking for. A is 4, b is negative 6, and 4 squared is 16, 6 squared is 36, 16 plus 36 is 52, so once we take the square root, we can see that c is indeed root 52. Now, how can we simplify a radical? To simplify radicals, it helps if you know your perfect squares. Perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. You get the picture. So what is the highest perfect square that goes into 52? 4 goes into 52. So you can rewrite 52 as 4 times 13. Because 4 times 13 equals 52. And the square root of 4 is 2. So therefore, root 52 simplifies to 2 root 13. So we can get rid of the root 52. We don't need that anymore. So now we can figure out what sine, cosine, and tangent are now that we have all three sides of the triangle. So now, what is the value of sine, cosine, and tangent? Feel free to pause the video and work out these examples. So sine theta is opposite over hypotenuse. So therefore, sine theta is -6 divided by 2 root 13. Now, 6 divided by 2 is -3, so it's -3 root 13. Or I meant to say -3 divided by root 13. Now, typically, whenever you have a radical in the denominator of a fraction, you need to rationalize the denominator. So we got to multiply the top and the bottom of the fraction by root 13. So it's going to be -3 root 13. The square root of a number times the square root of a number is the number inside. So we're just going to have a 13 on the bottom. So this is the value of sine theta. Now what about cosine theta? Actually, before we do cosine theta, let's find out the value of cosecant. Cosecant theta, we know it to be 1 over sine. But when you get into a situation like this, you want to know which one you should flip. You can flip any one of these fractions, but one of them is going to save you a lot of work. The one that you want to flip is the one that has the radical on the bottom. If sine theta is -3 over root 13, cosecant is -root 13 over 3. So you no longer need to rationalize this fraction. Now notice what's going to happen if you try to flip this one. Cosecant theta is also equal to -13 over 3 root 13. So now you have a radical on the bottom, so you have to rationalize it. So we've got to multiply top and bottom by root 13. Thus, cosecant is -13 root 13 divided by 3 times root 13 times root 13 is another 13. So you can cancel the 13s, and then you get this answer, -root 13 over 3. So it's a lot easier if you just flip this fraction. So now, what is the value of cosine? Based on a triangle. What's cosine theta? So cosine theta is equal to the adjacent side over the hypotenuse. So that's going to be 4 over 2 root 13. 4 divided by 2 is 2, so we have 2 over root 13, which we need to rationalize it. So cosine theta is going to be 2 root 13 over 13. So that's the answer for that. Now, if we want to find secant theta, don't find a reciprocal of this answer. Make sure you flip this one. So secant theta is going to be root 13 over 2. Now the last one that we're going to go over is tangent theta. What is the value of tangent theta? Tangent theta is opposite over adjacent. So opposite is -6, adjacent is 4. So it's -6 over 4, which, because both numbers are even, we could divide the top and the bottom by 2 in order to reduce the fraction. So it's -3 over 2. That's tangent theta. So therefore, cotan theta is the reciprocal of it. So cotan theta is -2 over 3. Now the next thing that we need to go over is the 30, 60, 90 triangle. Across the 30 is 1. Across the 60 is 1 times root 3, or simply root 3. Across the 90 is 2. Make sure you know this triangle. So let's say if you want to figure out what sine of 30 degrees is. Sine 30 is equal to the opposite side divided by the hypotenuse. So notice that 1 is opposite to 30. So therefore, sine 30 is 1/2. Now what about cosine 30? What is the value of cosine 30 degrees? So relative to this 30, the adjacent side is root 3, hypotenuse is 2. And keep in mind, cosine is adjacent over hypotenuse, based on SOHCAHTOA. So cosine 30 is root 3 over 2. Now what about sine 60? What is the value of sine 60? So sine is opposite over hypotenuse. Opposite to the 60 is root 3, and the hypotenuse is still 2. So sine 60 is root 3 over 2. Now what about cosine 60? So adjacent to the 60 is the 1, and the hypotenuse is 2. So cosine 60 is 1/2. Notice that cosine 60 is equal to sine 30. And sine 60 is cosine 30. Why is that? Cosine is the cofunction of sine. Cotangent is the cofunction of tangent. Cosecant is the cofunction of secant. The cofunction is equal to the function 90 minus x. So cosine x is sine 90 minus x. Whenever the cosine angle and the sine angle add up to 90, cosine equals sine. For example, cosine 30 is equal to sine 60. Cosine 20 is equal to sine 70, because 20 plus 70 adds up to 90. Cosine 0 is equal to sine 90. Sine 90 is 1, cosine 0 is 1. So cosine 15 degrees is equal to sine of what angle? So all you have to do to find a missing angle is 90 minus 15, so therefore this is 75. But now let's get back to the 30, 60, 90 triangle, because you can use that to find the values of larger angles. Now you need to understand the concept of a reference angle. The reference angle is always between 0 and 90. It's an acute angle. An obtuse angle is an angle larger than 90. A right angle is equal to 90. In quadrant 1, this angle represents the reference angle. In quadrant 2, the regular angle is over here, but the reference angle is between the x-axis and the blue line, so this is the reference angle. In quadrant 3, the reference angle is over here. The reference angle is always between the x-axis and the hypotenuse of the triangle that is formed. So if you have an angle in quadrant 1, the reference angle is equal to that angle. If you have an angle in quadrant 2, the reference angle is 180 minus the angle in quadrant 2. Now, if you have an angle in quadrant 3, the reference angle is the quadrant 3 angle minus 180. If you have an angle in quadrant 4, the reference angle is 360 minus the angle in quadrant 4. So let's go over some examples. So let's say if you have an angle of 60 degrees. What is the reference angle? So because the angle is between 0 and 90, the reference angle is equal to that angle. It's going to be 60 degrees. So if the angle is in quadrant 1, it's the same as the reference angle. Now let's say if the angle was 140 degrees. What's the reference angle? So 140 is in quadrant 2. So the reference angle is going to be 180 minus the angle in quadrant 2. So 180 minus 140, it's 40 degrees. To see it visually, here's 0. This is 90, 180, and 270. So 140 is somewhere in this area. So from the x-axis to this angle, that's positive 140 degrees if you travel counterclockwise. This angle on the inside between the x-axis and the hypotenuse of the triangle formed, that is the reference angle. So it's the difference between 180 and 40. So that's why this is equal to 40. It's the difference of these two angles. Now let's say if we have another angle. Let's say the angle is 225 degrees. So that's in quadrant 3. What's the reference angle? The reference angle in quadrant 3, it's going to be the angle in quadrant 3 minus 180. So that's 225 minus 180, which is 45 degrees. So 225 is right here. And the reference angle is always between the x-axis and this vector. So here it is. As you can see, it's the difference between these two numbers. So it's 45. The reference angle is always between 0 and 90. Let's try another example. Let's say the angle is 330 degrees. What's the reference angle? So the reference angle in quadrant 4 is 360 minus the angle in quadrant 4. So that's 360 minus 330. So it should be 30 degrees. So 330 is somewhere in this area. So starting from the x-axis, traveling all the way to this direction, that's 330. The difference between 360, which is the same as 0, and 330, that's the reference angle, which is 30 degrees. So it's between the x-axis and the hypotenuse of this triangle formed. So how do we apply this to a question? So let's say if you want to evaluate sine of 150. What can you do? Option 1, you can memorize the unit circle and look for 150 and pick the y value. Sine is associated with the y value. That's the first thing you do. Option 2, you could plug it in the calculator. Option 3, you can use the reference triangle. So the first thing we need to do is find a reference angle. 150 is between 90 and 180, which means it's in quadrant 2. The reference angle in quadrant 2 is equal to 180 minus the angle in quadrant 2. So 180 minus 150. So the reference angle is 30. Once you have the reference angle, you want to find the value of sine 30. So therefore, use the 30, 60, 90 triangle. Now this triangle I would commit to memory because it is very, very helpful. Across the 30 is 1, across the 60 is root 3, across the 90 is 2. So I'm going to draw it many times throughout this video to help you to commit that to memory. So sine, based on SOHCAHTOA, is opposite over hypotenuse. Relative to the 30-degree angle, opposite is 1, the hypotenuse is 2, so sine 30 is 1 over 2. Sine 150, therefore, is also 1 over 2. However, 150 and 30 may vary depending on the sign. You need to figure out if sine 150, if it's positive a half or if it's negative a half. The magnitude is going to be the same. They're both going to be 1/2. But sometimes it could be positive, sometimes it's a negative. Now, sine is associated with the y value. In quadrant 2, is y positive or negative? Because you have to go up the y-axis, y is positive. Therefore, since sine is associated with y, sine 150 is positive. So this is the value of sine 150. It's plus 1/2. Have you ever heard of the expression, all students take calculus? In quadrant 1, it's A for all. Quadrant 2, students, so S. Quadrant 3, take. And quadrant 4, calculus. So what does this mean? Relative to sine, cosine, and tangent, the A part represents sine, cosine, and tangent. All of them are positive in quadrant 1. All students. So S means that sine is positive in quadrant 2. So the other two, cosine and tangent, are negative. T for tan. Tan is positive in quadrant 3, but sine and cosine are negative. And then C for cosine. Cosine is positive in quadrant 4, but sine and tan are negative. So all students take calculus. Everything is positive in quadrant 1. Students, only sine is positive in quadrant 2. Take, tangent is positive in quadrant 3. Calculus, cosine is positive in quadrant 4. I don't know if you heard of that expression, but if you like abbreviations, this could be helpful. Personally, I just look at x and y and see what quadrant based on the sign of x and y. So, for example, if sine is positive and cosine is negative, that means y is positive and x is negative. I know x is negative to the left and y is positive as you go up, so this is quadrant 2. That's the way I see it. Now let's try another example. What is the value of cosine 240? You can use the unit circle, you can use the calculator, or you can use the reference triangle. Take your pick. Feel free to try this example. So let's find the reference angle first. In quadrant 3, the reference angle is the angle in quadrant 3, which is 240 minus 180. So the reference angle is 60. So we need to find the value of cosine 60. That's going to help us to calculate cosine 240. So let's draw the reference triangle. So we have the 30, 60, 90 triangle. Across the 30 is 1, across the 60 is root 3, across the 90 is 2. So we're looking for cosine 60. Cosine is adjacent, that's next to 60, over hypotenuse. So cosine 60 is 1/2, which means that cosine 240 will also be 1/2. But we got to figure out, is it positive or negative? So 240, we know it's in quadrant 3 because that's between 180 and 270. So cosine, which is associated with x, is it positive or negative in quadrant 3? Well, quadrant 3 is to the left. As you go to the left on the x-axis, it's negative. So therefore, cosine 240 is negative 1/2. And so that's the answer for that problem. Now, what about this one? What is tangent of 5 pi over 3? How can you evaluate this particular problem? So we have the angle in radians as opposed to degrees. So what you want to do is convert radians into degrees. To do that, take 5 pi over 3 and multiply by 180 over pi. You want the pi symbols to cancel. Now we can do 5 times 180 divided by 3, or we can do 180 divided by 3 times 5. It's easier if you divide first and then multiply. So what's 180 divided by 3? If 18 divided by 3 is 6, 180 divided by 3 is 60. So we have 5 times 60. Now if 5 times 6 is 30, 5 times 60 is 300. You just got to add the 0. So tangent 5 pi over 3 is the same as tangent 300 degrees. So now let's calculate the reference angle. So 300 is in quadrant 4. And the reference angle in quadrant 4 is 360 minus the angle in quadrant 4, which is 300. So we have a reference angle of 60. So we got to find the value of tangent 60 using the reference triangle. So across the 30 is what? And what's across the 60? Across the 30 is 1, across the 60 is root 3, across the 90 is 2. So tangent is opposite over adjacent. Relative to 60, opposite is root 3, and the hypotenuse is always across the box, so that's going to be 2. So tan 60, actually I take that back. Tangent is opposite over adjacent. Let's not forget SOHCAHTOA. So opposite over adjacent. Opposite to 60 is still root 3. But adjacent to 60 is right next to it. That's 1. So tan 60 is root 3 over 1, which is root 3. So therefore tangent 300 must also be root 3, We just got to figure out, is it positive or negative? And tan 300 is the same as tan 5 pi over 3. So 300 is in quadrant 4. Now, if you remember, all students take calculus. All is for quadrant 1. That means tangent is positive in quadrant 1. Students, that's sine is positive in quadrant 2, take tangent is positive in 3. So tan is positive in 1 and 3, which means that tangent is negative in 2 and 4. And since 5 pi over 3 is in quadrant 4, tan 5 pi over 3 is negative root 3. So here's another way you can check the answer. In quadrant 4, x is positive and y is negative. Now tangent relative to this angle is opposite over hypotenuse. Tangent is y over x. So if you have a negative number divided by a positive number, the overall result is negative. So tangent in quadrant 4 is negative. Now, what is the value of secant 7 pi over 6? So if you want to evaluate secant, evaluate cosine first. Secant is 1 over cosine. Now let's convert 7 pi over 6 to degrees. To convert it to degrees, multiply the radian angle by 180 over pi. So the pi's cancel. What's 180 divided by 6? Remember to divide first, then multiply. 18 divided by 6 is 3, so 180 divided by 6 must be 30, so we have 7 times 30. Now 7 times 3 is 21, so 7 times 30 is 210. Now if you want to go back from degrees to radians, multiply by pi over 180. So the degree symbol will cancel. So what's 210 over 180? What I would do is cancel a 0. So what's 21 over 18? Notice that both of these numbers is divisible by 3. 21 divided by 3 is 7, and 18 divided by 3 is 6. So you get what you started with, 7 pi over 6. So now you know how to go from radians to degrees and degrees to radians. So we're looking for 1 over cosine 210. Now the next thing we need to do is find a reference angle. So 210 is in quadrant 3, and a reference angle in quadrant 3 is the angle in quadrant 3, which is 210 minus 180. So therefore the reference angle is 30. So let's figure out what cosine 30 is equal to using the 30, 60, 90 reference triangle. So let's draw it. So we have 30, 60, across the 30 is 1, across the 60 is root 3, across the 90 is 2. So according to SOHCAHTOA, cosine is relative to 30, cosine is adjacent over hypotenuse. Adjacent is root 3, hypotenuse is 2, so cosine 30 is root 3 over 2. So if cosine 30 is root 3 over 2, what's cosine 210? Now 210 is in quadrant 3, and in quadrant 3 it's on the left side, so x is negative. Cosine is negative in quadrant 3. Remember, all students take calculus. C for calculus, that's quadrant 4. Cosine is positive in quadrant 4, and everything is positive in 1. So therefore cosine is negative in 2 and 3. So cosine 210 is negative root 3 over 2. So therefore secant of 210, or secant 7 pi over 6, keep in mind 7 pi over 6 is the same as 210. Secant is the reciprocal of cosine. So if cosine is negative root 3 over 2, secant is negative 2 over root 3. So since we have a radical on the bottom, we need to rationalize the fraction. So let's multiply the top and the bottom by root 3. So on top it's going to be negative 2 root 3. On the bottom, root 3 times root 3 is the square root of 9, and the square root of 9 is 3. So this is the answer. Secant 7 pi over 6, or secant 210, is negative 2 root 3 over 3. Now let's say if we're looking for cosecant 3 pi over 4. What is the value of cosecant 3 pi over 4? So cosecant is 1 over sine. And let's find out what 3 pi over 4 is in degrees. So let's multiply it by 180 over pi. So the pi's cancel. 180 divided by 4. When you divide something by 4, you want to find half of it 2 times. Half of 180 is 90, and half of 90 is 45. So 180 divided by 4 is 45. And 45 times 3, how can we figure that out? 40 times 3, if 4 times 3 is 12, 40 times 3 is 120. And 3 times 5 is 15, so 120 plus 15 is 135. So we need to figure out what sine 135 is. So let's find the reference angle. 135 is in quadrant 2, and the reference angle in quadrant 2 is 180 minus the angle in quadrant 2, which is 135. So the reference angle is 45. So we got to figure out what sine 45 is. So we can't use the 30, 60, 90 reference triangle. We need a new one. And the new one that you need to know is the 45, 45, 90 triangle. Across the 45s is 1. Across the 90 is root 2. So sine 45, let's choose this one. It's opposite over hypotenuse. So it's 1 over root 2. If you rationalize it, you'll see that sine 45 is equal to root 2 over 2. Which means sine 135 is root 2 over 2. We just got to figure out, is it positive or is it negative? 135 is in quadrant 2. And in quadrant 2, x is negative but y is positive. Y is associated with sine, so sine 135 is positive. So if sine 135 is root 2 over 2, cosecant 135, or cosecant 3 pi over 4, is the reciprocal of it. So let's reciprocate not root 2 over 2, but we need to flip 1 over root 2. It's easier if you do it that way. So cosecant is going to be just root 2 over 1, or simply root 2, and it's positive. So this is the answer. Now let's say if you wish to evaluate an angle that's larger than 360. Let's say sine 390. What would you do? If you get an angle that's larger than 360, find something known as the coterminal angle. So to find the coterminal angle, subtract 390 by 360, and you'll get 30. So 30 is over here, and this is 30 degrees. Now, if you want to figure out what 390 is, this is 90, 180, 270, 360, 390. So 390 and 30, they land at the exact same position. So even though they're different angles, because they land at the same point, they are known as coterminal angles. So sine 390 has the same value as sine 30 because they land in the same quadrant on the same position. So we know that sine 30, based on the 30, 60, 90 triangle, sine is opposite over hypotenuse. So relative to 30, it's opposite over hypotenuse, or 1 over 2. So since sine 30 is a half, sine 390 is also a half. Now what should you do if you have a negative angle? So let's say if you want to evaluate cosine negative 120. What's the answer? If you have a negative angle, simply add 360 to it to make it positive. So negative 120 plus 360 is positive 240. So that's the positive coterminal angle of negative 120. So to draw a picture, 240 is in this region. Keep in mind this is 180 and this is 270. So this is 240. So if you travel counterclockwise, that's opposite the direction of a clock, this is 240 degrees. Now if you have a negative angle, you need to travel clockwise or in a direction of a clock. So this is negative 120. Notice that negative 120 and 240, they land at the same position. So they're coterminal angles of each other. So let's finish this problem. So we know that cosine negative 120 is the same as cosine 240. Now 240 is in quadrant 3, so the reference angle is going to be the angle in quadrant 3, 240 minus 180, so it's 60. So using the 30, 60, 90 triangle, this is 1, this is root 3, across the 90 is 2. So cosine 60 is adjacent over hypotenuse. So therefore cosine 60 is 1 over 2. So 240 is also 1 over 2. But cosine is negative in quadrant 3, so this is negative a half. So now you know how to evaluate a trig function with a negative angle. Simply add 360 to it and then just do what you've been doing. Now sometimes you might get a question that asks you to find a positive coterminal angle and a negative coterminal angle. So let's say if you have the angle 40. Write one positive coterminal angle and one negative. To find the positive coterminal angle, simply add 360, so that will be 400. And to find a negative coterminal angle, subtract 360 from it, so that would be negative 320. So that's how you could find other coterminal angles. You can add or subtract by 360. Now, if your answer is in radians, let's say if you have a question that asks you to find a positive and a negative coterminal angle for, let's say, 5 pi over 6. 360 is the same as 2 pi. So what you want to do is you want to add 2 pi and you want to subtract 2 pi. So to add, you need to get common denominators. 2 pi over 1 is the same as 12 pi over 6. You need to multiply top and bottom by 6 so you can get the same denominator. So 12 plus 5 is 17. So 17 pi over 6 is the positive coterminal angle of 5 pi over 6. Now to find the negative one, let's get common denominators. So it's going to be 5 pi over 6 minus 12 pi over 6. So 5 minus 12 is negative 7. So it's negative 7 pi over 6. That's the negative coterminal angle of 5 pi over 6. Now let's move on to inverse functions. We know that sine of 30 degrees is equal to 1/2. So what is the inverse sine of a half? Since sine 30 is a half, the inverse sine or the arc sine of a half is 30 degrees. Now sine of 150 is also positive a half. Yet inverse sine of a half does not equal 150. I really want to stress that. The question is why? Typically, when you have an inverse function, you need to switch x and y if you want to find an inverse function. So in this case, we need to switch the angle and the value. Sine of an angle, like 30 degrees, is equal to a value such as 1/2. The inverse function of sine, whenever you use the inverse function, it's the inverse function of a value, and that equals an angle. So whenever you want to find the inverse function of something, you're looking for the angle. If you want to find the sine or cosine of an angle, you're looking for the value. But why is it that inverse sine of a half doesn't equal 150? You need to realize that the inverse functions have restricted domains. Inverse sine can only exist in quadrants 1 and 4. It doesn't exist in quadrant 2. That's why inverse sine 1/2 does not equal 150, because 150 is in quadrant 2. Inverse tangent also exists in 1 and 4. Inverse cosine exists in 1 and 2. Now, inverse cosine can only be between 0 and pi, or 0 and 180. Inverse sine has to be between negative pi over 2 to pi over 2. So, let me illustrate the importance of that. So let's say if you want to figure out what inverse sine of negative 1/2 is? What is inverse sine negative 1/2? Now, we know that sine of, let's say, 210, which is 7 pi to 6, sine 210 is negative 1/2. Sine 330, let me use radians. So 210 is the same as 7 pi to 6. That's in quadrant 3. And sine 330, which is the same as 11 pi to 6, is also negative 1/2. And also sine negative pi to 6, which is negative 30, is negative 1/2. So what is the inverse sine of negative 1/2? So keep in mind, inverse sine exists only in quadrants 1 and 4. 7 pi over 6, which is 210, is in quadrant 3. So inverse sine doesn't exist there. So it's not going to be 7 pi over 6. Now, 11 pi over 6, that's 330 degrees. That's about right here. That's in quadrant 4. And negative pi over 6, which is negative 30, that's also in quadrant 4. So this is negative 30, and this is 330, which is 11 pi over 6. So which one is it? Is it 11 pi over 6 or negative pi over 6? Now, keep in mind, when we drew this, we said inverse sine exists in quadrants 1 and 4. But also, the domain of inverse sine is between negative pi over 2 and pi over 2. It has a restricted domain. So quadrant 4, you need to use an angle between 0 and negative 90. Not 270 and 360. Because inverse sine doesn't exist there. So it's not going to be 11 pi over 6 because it's not between negative 90 and 0. It's not between negative pi over 2 and 0. So it's going to be negative pi over 6 because that's in the restricted domain of inverse sine. Negative 30 is between 0 and negative 90. So it's negative pi over 6. So whenever you're dealing with inverse functions, be careful because they do have restricted domains. So let's work out some examples. Evaluate inverse cosine negative root 3 over 2 and inverse tangent negative 1. So inverse cosine is negative in quadrant 2. So cosine of what angle in quadrant 2 is negative root 3 over 2? The reference angle, if you draw the 30, 60, 90 triangle, this is 1, root 3, and 2. The reference angle has to be 30. Cosine is adjacent over hypotenuse. That's root 3 over 2. So cosine 30 is positive root 3 over 2 in quadrant 1. Cosine 150 is negative root 3 over 2. We don't want to use cosine 210. Even though it's negative root 3 over 2, 210 is in quadrant 2. Inverse cosine is negative. 210 is in quadrant 3. And inverse cosine is negative in quadrant 2. So we want the quadrant 2 angle. So since cosine 150 is negative root 3 over 2, this is thus 150 or 5 pi over 6. But it doesn't equal 210 because 210 is in quadrant 3 and inverse cosine does not exist in quadrant 3. So this is the answer for the first one. So now what is inverse tangent of negative 1? Inverse tan is negative in quadrant 4. So the angle has to be between negative 90 and 0. So first, let's find a reference angle. Now, which two triangles should we use to find a reference angle? Should we use the 30, 60, 90 triangle? Or should we use the 45, 45, 90 triangle? Which one would you use? Now, if we use the 30, 60, 90 triangle, you need to divide two sides, opposite over adjacent. If it's 1 over root 3, that's not going to give you 1. Root 3 over 1, it won't work. The only one that's going to work is the 45, 45, 90 triangle, because 1 over 1 is 1, which means that it's 45. Tangent 45, opposite over adjacent, 1 divided by 1 is 1. Now, tangent of 315 which is in quadrant 4, that's negative 1. But inverse tan of negative 1 does not equal 315, because 315 is not between negative 90 and 0, even though we have the right quadrant. Tangent of 135 is also negative 1, but that's in quadrant 2, and inverse tan does not exist in quadrant 2, so we can't use these. However, tangent of negative 45 is equal to negative 1. Negative 45 is in quadrant 4, and negative 45 is between negative 90 and 0, so this works. So the answer is negative 45, which is the same as negative pi over 4. So that's inverse tan of negative 1, negative pi over 4. What would you do if you saw this on a test? Sine inverse cosine 7 over 25. What is the answer? Even though this question may look hard, it's not hard. It's actually easier than what we've been doing. So notice that we have a positive value, 7 over 25. So therefore, we need to draw a triangle in quadrant 1. You always want to draw a triangle like this, where it's with the x-axis, not with the y-axis. And here's theta. Now, cosine is adjacent over hypotenuse based on SOHCAHTOA. So this is 7, and the hypotenuse is 25. This is positive 7 because it's on the right side. X is positive on the right side. Now, we got to find the missing side. So what is the missing side here? You can use a squared plus b squared equals c squared, or you can simply know the special triangles. This is the 7, 24, 25 triangle. So the missing side is positive 24. So now what we got to evaluate is sine. Keep in mind the inverse cosine of a value is equal to an angle. What is the angle? It's theta. So what we're really looking for is sine theta. Inverse cosine 7 over 25 is theta. So that's the entire problem. Once we figure out what sine theta is, we have the answer. Sine theta is opposite over hypotenuse. So sine theta is 24 over 25. And that's all you got to do for this question. So now it's your turn. Try this one. Tangent inverse sine negative 15 over 17. So notice that we have a negative value, negative 15 over 17. And inverse sine is negative in quadrant 4. Even though sine is negative in 3 and 4, inverse sine does not exist in quadrant 3. Therefore, we should draw the triangle in quadrant 4. So here's theta. Sine is opposite over hypotenuse. The opposite side is negative 15. And because this side is going down along the y direction, it's negative. The hypotenuse is always positive. So what's the missing side? To find the missing side, you could do 17 squared minus 225 squared, and then take the square root of that result. Or you could know the special triangle. This is the 8, 15, 17 triangle. But if you want to use the Pythagorean theorem equation, 17 squared is 289, 15 squared is 225. 289 minus 225 is 64, and the square root of 64 is 8. So you could do it mentally that way as well. Now that we have all three sides, let's figure out what tangent theta is equal to. So tangent theta is equal to the opposite side over the adjacent side, based on SOHCAHTOA. So it's negative 15 over 8. And so that's the answer for this problem. Now try this one. Cosine inverse sine 4 over 7. So because it's positive, inverse sine exists in quadrant 1. So opposite to theta is 4, the hypotenuse is 7. So what's the missing side? So this is not a special triangle, so we have to use the Pythagorean theorem. Because we're looking for one of the legs of the triangle, which is less than 7, we need to find the difference of squares and then take the square root. What's 7 squared? 7 times 7 is 49, and 4 squared is 16. So the difference of the squares, 49 minus 16, that's going to be 33. And then we have to take the square root of 33. So it's root 33. So we're looking for cosine theta, which is adjacent over hypotenuse. So it's 7 over root 33. That's the answer. But wait, we do need to rationalize it. So the final answer is actually 7 root 33 divided by 33. Now let's try one more example. Tangent inverse cosine x divided by 3. What would you do if you saw that on a test? And let's put a negative sign in front of it. So inverse cosine is negative in quadrant 2. So here's the box, here's theta. So cosine is adjacent over hypotenuse. X is negative as you go to the left, so this is going to be the negative x, and the hypotenuse is always positive. So we got to find the missing side. Let's call it b. So using the equation a squared plus b squared is equal to c squared. A is basically negative x, b, we're looking for that, c is 3. So negative x times negative x is positive x squared. And 3 squared is 9. So if you solve for b squared, you need to subtract both sides by x squared. So b squared is 9 minus x squared. So now we got to take the square root of both sides. So b is equivalent to the square root of 9 minus x squared. So now we can evaluate tangent. So tangent theta is equal to the opposite side over adjacent. So tangent is negative root 9 minus x squared divided by x. You can move the negative from the x to the front if you want. So if you have it in terms of x, simply make the triangle, find the missing side, and then use SOHCAHTOA to figure out what the outer function is. So there's more topics that we can go into, like double angles, half angles, sum and difference formulas, verifying trigonometric identities. I've created a video on that as well. You could look for it on YouTube. But I'm going to stop here. I think we've covered a lot of material today. So thanks for watching this video, and have a great day.